Hello everyone. In this video, we are going to discuss about UDP header structure and fields. In this video, we will discuss introduction to UDP, which includes what is exactly UDP, what is datagram, and features of UDP. Then we will discuss in detail the UDP header structure and UDP header field, and finally we will summarize this session. So, firstly, what is exactly the UDP? UDP is the transport layer protocol used for transmission of data over the internet. It is connectionless, lightweight and fast transport protocol used for communication over a network. Unlike TCP, which is a transmission control protocol, UDP does not establish any connection before sending the data, making it ideal for applications that require speed over the reliability. To understand the basic idea about the UDP, let's imagine that sending a voice message on a WhatsApp. If a small part of audio get lost, the message is still understandable. Similarly, UDP ensures the fast delivery without delays caused by the retransmission. After it, as I said, UDP is a user datagram protocol. But what is exactly the datagram? So, the datagram is a self-contained independent packet of data which travels across a network without requiring a connection. Each datagram is treated separately and may arrive out of order or not at all. So, to understand about the datagram, let's think about the postcards similar to it. Postcards were sent via the traditional mail. Each postcard, which is similar to datagram, reaches the recipient independently without guaranteeing the order of arrival or confirming the delivery. So these are the basically UDP and the concept of datagram. So let's discuss about the features of UDP. The first feature of the UDP is connectionless. That means there is no need to establish a connection before sending the data, as we discussed earlier. The next feature of UDP is it is unreliable. It means that there is no any acknowledgement or the retransmission if the packet get lost. As we know, in UDP, the data is transmitted over the multiple paths or can be transmitted with change in order. So, there can be possibility of the loss of the data. But for this, there is no any acknowledgement or the retransmission if the packet or the datagram get lost. The next feature of UDP is low overhead. It means that the small header size of the UDP header, which allows the faster transmission and usage of the lower bandwidth. It supports the broadcasts and multicast, hence useful for the applications like DHCP and live streaming. There is no any flow control or the congestion control. As I said earlier, the datagram in the UDP can be transferred through multiple paths over the network. Hence, there can be possibility of causing the congestion of the data, but there is no any flow control or the congestion control. The sender transmit the data without adjusting the network condition. So let's understand the UDP header structure. The UDP header is of 8 bytes, that is 64 bits long, and consists of 4 fields, each of 2 bytes, which is 16-bit long. So these four fields are source port, destination port, third one is the length, total length port, and last one is the checksum. The remaining part of the datagram is a data. UDP port field are each of 2 bytes, which is 16-bit long. That is, the range of port number is defined from 0 to 65,535. The port number 0 is reserved. Port number helps to distinguish different user requests and processes. So let's further discuss about the UDP header fields in detail. As I said, there are 4 fields in the UDP header. each of 2 bytes. Here, the first one field is source port. The source port is of 2 bytes, which is 16 bits, which defines the port number of sender, which helps the recipients to know where to send the response. If no response is needed, this field can be set to 0. To understand the source port easily, let's imagine you are calling a friend. Your phone number, which is similar to source port, tells your friend where the call is coming from. The second field in UDP header is destination port, which is of 16 bit, that is 2 bytes, which defines the port number of recipient. It ensures the data is delivered to the correct application on the receiver system. To understand this, let's consider when you visit a website, your browser sends the request to port 80, which is HTTP, or 443, which is HTTPS on the web server. The third one, header field, is length. It specifies the total size of UDP datagram, which contains header plus data. The maximum length of uh, datagram can be 65,535 bytes, which contains both the header and data. The minimum length of the datagram can be 8 bytes, which only contains the header. So this is basically the concept of length. To understand the concept of length in detail, let's consider one example that you have sent a short message over the UDP with the size of 28 bytes, which contains 8 bytes of header and 20 bytes of data. The next one field is checksum. Checksum is also of 16 bits, means 2 bytes of length. It is used for error detection during the data transmission. It is optional in IPv4 but mandatory in IPv6. If an error is detected, the receiver discards the packet instead of requesting the retransmission. It ensures the data integrity during the transmission. To understand the checksum, consider the real life scenario. When we are sending a money transfer, the bank verifies the account number before processing the transaction. Similarly, UDP checksum verifies the data integrity. So let's finally conclude the session. As we discussed, UDP is a fast connectionless protocol which is best suited for time sensitive applications where some data loss is acceptable. Its simple header structure, which is of 8 bytes, makes it efficient for real time communication, unlike TCP, which prioritizes the reliability over speed. Thank you.